The booster design was arrived at, that's being done by the Marshall Space Flight Center, and that design was arrived at or chosen after evaluation of a variety of things, which included huge airplanes which could fly straight up and then return to the launch site under the power of air-breathing engines. It included evaluation of various kinds of liquid-fueled booster stages, and the choice of the solid rocket booster was made after a competitive engineering evaluation of all these concepts. Now, in the launch, the boosters will eventually be recovered. They'll be lowered by parachute and then recovered and actually just towed through the ocean like barges back to KSC, where they'll be hoisted out and dried out and cleaned up and reloaded with propellant and launched again. The external tank is not reusable. It's just a big hollow pair of tanks that looks like a great big cigar, and that's abandoned at a velocity that's just suborbital, and on launches out of Kennedy Space Center, it goes into the Indian Ocean in pieces on each launch. As far as tests of these, the external tank, first version of the external tank is not yet fully assembled, but it is in final stage of completion at the Michoud Assembly Facility in New Orleans. The booster was first tested this past Monday at Thakal in Utah. That was the first full-scale firing of the booster configuration that we will use, and it was, as far as we are able to tell at this point, a completely successful test. So many things are coming along. About testing, we have a lot of major tests in being, which fall in the category between the development test that I mentioned and the test of the complete airplane. We have two major tests going on. One is the structural test, in which we built just an airframe without any systems being attached to it. It's just the structure of the airframe itself, of the orbiter. That's nearing completion out at excuse me, in California. Rockwell's building that. Another major test article was called the main propulsion test article. The orbiter element of that was completed about 2 months ago and has already been shipped to Mississippi. It's in the test stand. The first tank built, first external tank, will come from New Orleans up to the test facility at Mississippi and will be integrated with it there. And the first 3 flight quality engines will be attached to the orbiter test article there, and we will conduct a series of main propulsion tests in the test stand there in Mississippi.
This will determine maximum thrust and aerodynamic properties and things like that?
Well, we won't be looking at aerodynamic properties. We're essentially looking at the capability of the main engines and the tank and all the interconnecting plumbing to work properly together to ensure that we are able to get the performance necessary to achieve orbit on the first flight.
I see. So basically what we have is in the entire shuttle, we have a tank, a main tank attached to the orbiter, which provides fuel for the main engines of the orbiter. And then you have 2 solid rockets attached to this main tank, which also fire. And the 2 solid rockets are recoverable. The main tank is not. And the shuttle, of course, the flying section is, of course, recoverable. It comes in like an airplane. All right, that seems very interesting. I had read in, I guess, back in 70 and 71, when I was more into the space program myself, about the various ideas they were considering, and I don't remember this particular one. The 2 I remember was the big airplane idea and then the liquid rocket idea. So this definitely is different, I suppose, than anything previously. Getting back to the orbiter itself, you say that it has 5 computer control systems. Are these all oriented around just control of the vehicle itself, or do they do other things, navigation and things like that?
These computers do all the calculating jobs that are to be done on board the vehicle. It includes a simulation of navigation data and the output of both guidance and navigation information. They provide control of the vehicle by orientation of the engines during boost, and this is, of course, a very quick reaction kind of job to keep the vehicle balanced on the thrust of the engines. They provide the control signals to the booster engines, or the movable nozzles on the boosters. They provide the aerodynamic control of the vehicle as it re-enters. Now that's again a computing job. There's a system of inertial measuring units and gyros on the vehicle which provide the basic stability information necessary for the computers to compute what control motions are necessary to maintain the attitude or rates that you're commanding from the cockpit. In addition to that, the computers control the redundancy of the vehicle. They will automatically switch out failed components if switching them out is necessary on a time-critical basis. And they drive all the pilot's displays. They take all the motions of the pilot's input on the controls and translate those into the electrical signals which go to the control surfaces for any phase of flight. They're truly the nervous center of the system, and if you try to create an analogy to the human body, you'd have to say the computers are the brain. Absolutely.
Looking at some of the things the shuttle is going to have to do, you read in the papers about the fact that it will be perhaps the first attempt of the United States to go up and take what they've already put up there and fix it. Some of the old payloads that have been put up by the various units. I've also heard that the shuttle will be used to make the old Skylab re-enterable into the atmosphere and things like that. Can you tell us a little bit about what the once the shuttle becomes airworthy or spaceworthy, I suppose, some of the things that it will be have to do, some of its projects?
Okay. The intent of the Space Shuttle is to provide for this nation and other participating nations a low-cost way to operate in space. And we say low cost, and we mean that. We also would like to point out that the Space Shuttle offers new capabilities in space, which includes things like you mentioned a moment ago, the capability to go to a payload and repair it if it has malfunctioned on orbit. We can go to a payload and service it, such as a replacement of photofilm or taking from an active payload or spacecraft that's already up there. We can take exposed film and bring it home. We can refuel vehicles which may need to have their attitude control gases replenished. One of the most interesting capabilities is to take a vehicle which is to be launched, carry it to orbit, and check it out on orbit, make sure that it's functioning properly before we release it. And if it's not, we can bring it home. And this, of course, for those of the audience who follows space operations closely, they probably realize that usually if you have a malfunction, it occurs during the launch phase, and you frequently find yourself on orbit with a dead bird. Unfortunately, that's true. The shuttle offers the opportunity to check that bird before you release it on orbit, and thereby achieve the savings of being able to bring a perfectly good payload home and fix some flaw and take it back for a successful mission as opposed to a lost mission. We'll also have the capability to carry to Earth orbit payloads which have their own propulsion system and which are capable of going on to orbits of energy or altitude far greater than we can achieve with the orbiter.